All right, so let's get into some case studies, and I think that this is where the rubber meets the road, right? So it's fine to hear me talk about all this stuff and hear the history and what's going on, but what's happening in real life. So our first case study is Linda Tool in Brooklyn, New York. Okay, and Linda Tool is a contract manufacturer in aerospace, military, and they serve a wide variety of industrial clients. So some of you may be in that same mode, or you may have machining operations in your facility. And over the years, to become competitive or stay competitive, you have to continue to reinvent yourself. Well, Linda Tool has done that. They were established in 1955. And they've evolved with the times in order to remain competitive and offer continued superior service and thrive as a company. So let's look at what some of their challenges were. The challenges are price pressure, right? We're always under price pressure. You always have to produce more for less. It's a continual problem and competitive need. Again, the skilled labor portion of things. How do you hire skilled labor so they can come in and be effective right away? Controlling your process so that time after time, if you do a batch of parts this month and you have to run them again next month, how do you control that process so that you can produce consistent quality month after month, year after year? Well, one thing they realized was that centralized QC was a constant bottleneck for them. So they had that scenario where there was a QC lab and there were 2 inspectors that were skilled to use all the measuring devices, and they were overloaded. They were overwhelmed. So, machinists were bringing parts in and said, oh, hey, I got this first article. Can you run this for me? And it's just taking a long time because in the meantime, while they said, I can't get to that right now. I'm busy with Joe's parts. You're going to have to wait. I'll get to it later this afternoon or tomorrow morning. So what does that machinist do in the meantime while he's waiting for his parts to get out of the QC lab? So the solution was to move more of the inspection process to the shop floor near manufacturing. So the key to this is how do you take this technology and put it into the hands of the people on the shop floor so that they can be effective making these measurements? So you have to think about this, right? Because it can't just happen instantaneously or automatically. So what they did is they utilized tooling for easy inspection setup. And then what they did is they took those inspectors that had that specialty, and now they went out to the shop floor and they helped the operator. So they were enablers. They were helping other people by effectively magnifying their knowledge out to the shop floor. So that, in this case, we see an optical comparator being used, and when properly set up and the operator is properly trained, they can make those decisions very quickly without having to wait for that bottleneck to clear to get their part out. Another solution on the CMM, big CMM user, and again, utilizing that tooling. If you can see here, I think this is inspection arsenal tooling, and they have fixtures for their parts. So it eliminates that setup time and the programming that's necessary. So the machinist is able to actually put those parts onto the CMM, start the program, and the CMM will measure the part, collect the data, and those on-floor specialists can assist, enable the process, and then also help analyze the data to make sure that parts are meeting specification. And here's a great shot of the tooling that's used. And I want to give a special thanks and acknowledgement to David Holmes and Michael DiMarino. They're here this morning with us from Linda Tool. Thanks, guys, for sharing your story about what you're doing. Really appreciate that. And they'll be here later, so if you guys have questions for them and maybe some of what you're hearing today resonates with you and you're saying, oh, that's kind of where we're at and we're having some trouble, Michael and David are here and they can answer some of your questions. So the results have been amazing for them, and it's allowed them to really speed things up and again remain competitive in a very competitive environment. Another similar story, this is BC Instruments out of Ontario, Canada. And somewhat similar, precision machining since '71, serving lots of different key industries like injection molding and aerospace. Very, what I call demanding industries like power generation. And they have 100 people on the shop floor in 5 different locations, and they have to keep all these things running at the same time. They have to be able to share data. They need to be able to offer solutions to their customers quickly. So they recognize that to remain competitive, they need to shorten their lead times. They need to get the process dialed in so that they can be more effective at measuring their parts and get rid of that bottleneck. So instead of looking at the QC process as a curse, they're looking at it as an additive element to the manufacturing process, which is what it needs to be. So they decrease their downtime. And in some cases, they had parts that were require 100% inspection. So how do they do that? How do they do that quickly? Well, one of the things that has evolved over the past few years with continuing accuracy and resolution of things like video cameras and processing speeds in computers, advanced software, is we're able to take more of a part and image it in a larger field of view. So in the early days of video technology, you were limited to higher magnification optics, and you had to really kind of magnify that part to be able to take features. Well, that's somewhat slow, right? Because now you're having to discretely take points and move around the part, so it takes more time. So when we can image more of the part in the field of view, we can do things much faster. So that's kind of where the technology is going these days. It's not the only way to solve the problem, because sometimes that can be overused, but it is where things are going. So having a system that has that flexibility where you can have a large field of view capability and then also higher magnification capability tends to be the balance, right? So for BCI, what they did is they invested in new video technology, and now they can utilize this system to measure parts, sometimes 100% in the field of view. They can rapidly measure the entire part, including threads. And again, here they're taking their DXF files and comparing the results to the DXF file. So it helps take away some of that uncertainty for the operator, and it allows them to have the versatility of a system like this to address many, many different types of applications. So you can see here, this system actually works in 2 orientations. So it'll work in a vertical mode, or it'll work in a horizontal mode. It's like most optical comparators are a horizontal mode type machine where the optics are in a horizontal path. And most traditional video measurement systems are vertical. And so this system will actually function in both modes. So it gives added flexibility and versatility in the use of that system. So they're able to actually identify things like tool wear. So if you're, one of those things we talk about is how fast you can make parts. But if you're making those parts so rapidly and you're not paying attention to things like tool wear and you're not catching that quickly, we could make a lot of scrap in a hurry, right? And that's very costly to be producing scrap. So that's really important. That's one of the things that they've identified, and it's helped their process tremendously. They've actually saved lots of times where in some cases they were measuring parts, they would only measure a few of the features and it would take them minutes. Now they're measuring 100% of the part and it's taking them seconds, and they're getting more data. So it's really powerful how you can use this information. So a special thanks to Roger Konzelman and BCI, and also Canadian Metalworking Digest, who actually published a story on BCI, and they participated in this study as well. And this article's, I guess, just being released in this issue that's here at the show.